just kind of want to give you guys a little background into who we are, and welcome Paul for doing the storage options for big data solutions in Azure. Paul's one of our actual trainers here and senior cloud architects with Opsgility. And just to let you kind of understand what we do, I'd like to introduce you to Opsgility. So we're basically the global leader in Microsoft Cloud Readiness. We offer multiple self-paced on-demand classes that are focused on Microsoft Azure. We also do Office 365, Dynamic CRM, and also include classes for Microsoft certification exam preparation, among many, many more. So we also do instructor-led training, both virtual and in person. We can range from enabling your sales team to sell cloud-based solutions, deeply technical training for IT professionals, data specialists, DevOps, and of course, cloud developers. So our newest offering is actually the Cloud Sandbox, and that basically is the ability to provide controlled access for Azure testing and development or training for an organization of any size. And then lastly, we do cloud readiness planning. And this is, do you need help moving with your organization to the cloud? Well, we can kind of identify all those skills gaps with your company. We can utilize our customer success team and our senior cloud architects to help identify your needs and create kind of a customized strategic plan to ensure your readiness budget is invested wisely and efficiently. So that's kind of who we are. We offer multiple classes. Definitely our Azure Sandbox for saving money on development, testing, learning, and then all kinds of different online courses and over 200 plus hands-on labs. So that is who we are. And just in case you guys are interested, if you wanted to kind of look at our course and see what we have to offer on demand, you can do a try Opsgility promo code at opsgility.com, and you can kind of look at our current library, and it's constantly growing. So, and then if you wanted a free pilot or anything, just contact us at sales@opsgility.com. All right, I'm just gonna go ahead and hand you guys over to Paul. We'll get started, and you guys, thank you again so much for attending Opsgility's webinar today. All right, Paul, I'm going to go ahead and make you the presenter. You guys can get started.
Okay, thank you, Ashley. Let's see. If it's okay. All right, should be showing my screen here in just a second. Okay, so today we're going to talk about big data in Azure, and specifically we're looking at predominantly on big data storage options that you have. Before we get started, a little more background on me. My name is Paul Burpo. I'm a senior cloud solutions architect at Opsgility. Before I came to work at Opsgility, I worked for Microsoft for about 15 years. I also had some other roles with some major retailers in between that time, where I was a data architect for them and did a lot of big data work. With the move into Opsgility, we've obviously started building up a data practice last year, and we are now offering a big data class. So just to sort of plug the next upcoming big data class, we have a designing and implementing big data analytics solutions that targets the 70-475 certification. The dates for that, it starts on March 6th, then it runs 5 days. You can use this registration link to get more information about the class, what it covers, etc. The price is $29.99, but you can use the OpsLove promo code that is still active to get 14% off of that price there. So I'll put the slide back up at the end in case anybody is interested in that. If you have any direct questions about it, you can ask me at the end of the webinar, and I'd be happy to answer that. So sort of the agenda that I'm going to follow today is I'm going to kind of make a case for running big data solutions in Azure. And specifically, we're going to talk about the Azure Data Lake Store, Azure Data Lake Analytics, just because it sort of goes hand in hand with the Data Lake Store. And then we're going to talk about HDinsight. So case for big data. So since most of you are solutions architects, I'm going to assume that everybody kind of knows what the Lambda architecture is. If you're not, I'll do a brief run through of it just for those who are not. If you look at most big data solutions out there, they are going to be some variety of the Lambda architecture. Sometimes a solution may just be a subset of the architecture. You may just have a real-time ingestion path. Other times it's the complete Lambda architecture. And what defines this Lambda architecture is that it has 3 layers: the speed layer, which is usually called the hot path, the batch layer, which is usually called the cold path, and the serving layer, which is generally consists of BI tools or visualization tools, and sometimes people put the batch view components into the serving layer as well. But that's semantics at this point. So what we're going to focus on today is more the Azure services that I have highlighted here, predominantly Blob storage, Azure Data Lake, Azure Data Lake Analytics, and HDinsight. And that's kind of where those fit. You'll also notice there's HDinsight up in the speed layer, and we'll talk about the flexibility that HDinsight brings a little bit later. So the first topic is the Data Lake Store, and we'll be going deeper into each of these. I'm just going to kind of briefly summarize each one first, and then we'll go back through each one. So Data Lake Store is generally, you think of this as HDFS for the cloud. So this is the Hadoop file system in the cloud. It's unique in cloud storage because you can store any number of files of any size into a single store. You don't have to have, you don't have any size limits one way or the other. Data can be stored in its native format. It supports enterprise-grade access control and encryption, and it's optimized for analytic workloads. So this is sort of in Azure, Data Lake Store is the gold standard for big data storage. Sort of hand in hand with that is Azure Data Lake Analytics. And Data Lake Analytics is built on Yarn, which is the operating system for Hadoop clusters. It is unique in that it is elastically scalable on a query by query basis. That's its big selling point. It does introduce a new language, USQL, which combines SQL and C#, and this is very popular, especially with Microsoft shops where you might have BI developers or database developers that come from a SQL background. They can easily migrate into USQL. It's very SQL-like. It's very easy to transition from one to the other. It also supports federated queries across multiple Azure data services. So that's another sort of underrated feature of Data Lake Analytics that we'll talk about. And then it supports enterprise-grade features as well. So Azure HDinsight is effectively, this is just Microsoft's Hadoop in the cloud. So this is the Hortonworks data platform. If you are familiar with the big data ecosystem, the main players are usually considered Cloudera and Hortonworks, and then MapR as well. And then there are a couple others that don't have quite as much market share, but those are the main ones. This HDinsight is based on the Hortonworks data platform, and Microsoft works closely with them to build HDinsight, and they are pretty close to lockstep as far as what's released and what's available in the build, and we'll talk about that more later. What's unique about HDinsight is the flexibility of its deployments. It's deployed a little differently than when you would typically deploy Hadoop clusters on-prem, so we'll dig into that a little bit more later. So why would you use cloud for big data? This is, to cloud engineers, this will be a pretty obvious sell, but for those who are not used to dealing with the cloud, in a traditional Hadoop environment, you typically have a cluster. You design it, you build it, you scope out the size, you get some approval for capital expenditures, and you buy a bunch of hardware, you order the hardware, you wait for, anywhere from a week to months, depending on where the hardware is in the build cycle. You build your cluster, you configure it, Then you set up all your folders, security, and you start adding data and develop queries. So day one, you might, and I have an extreme example here. Nobody would probably deploy a 2-node cluster in an on-prem environment, but let's just say you have a 2-node cluster here, no data, no usage, everything's just sort of zeroed out. So move forward about 180 days, and your 2-node cluster starts filling up, and you're running low on space. So the natural response is to double the number of nodes to free up space. And the reason that it's like this is because in on-prem Hadoop clusters, normally your storage is local to each node, and you have multiple copies of your data on each node, so that the multiple copies allows you to lose a single node without losing the data, but at the same time, you still have to keep data on each node. So when you want to add more storage, you basically are looking at adding more nodes. So you add more nodes, you're lucky you can get your servers in a couple of days. You integrate those servers into the cluster, redistribute your data, and everything looks fine. Well, now that you've got more storage and people are starting to see value in your system, about a year later, you start seeing higher CPU utilization. You've got more users coming in, they're using your cluster, and so now you have to do something about the CPU utilization. And to deal with that in Hadoop, you would again add more nodes to compensate for that, and then you would end up with an 8-node cluster, plenty of storage, CPUs in check. And then this process can kind of go on, and what'll typically happen is you'll hit some point where you've sort of leveled off and you kind of got a handle on data growth, but in theory, this could go on indefinitely where you're constantly adding to the cluster. So the cloud approach to big data is basically to have all your data stored in a single location, either Blob storage or Azure Data Lake stores, and then spin up as many clusters or compute that you need. So if you want Azure Data Lake Analytics to do some type of batch processing, and then you want to have an ETL HDinsight cluster that does ETL processing, you have that ability there. And then you could add another ad hoc cluster designed strictly for people who have access and want to run Excel or something against their data. The beauty of this is that I can add as many clusters as I want to the same data set, and I can also scale individual clusters to meet the demand for that particular type of load. So let's talk a bit about big data storage organization. So you typically have different environments that you're hosting out of a single storage account or data lake store. And it really, at this point, it wouldn't matter whether we're talking about a storage account or if we're talking about a data lake. So I've got some typical ones here: raw, staging, trusted, and sandbox. And so the raw data is where the ingested data is brought in. So this ingested data comes from whatever data source you have out there. This could be IoT data, it could be batch imports from OLTP systems, whatever. It would just get dumped to raw data. And the best practice is generally to not touch the raw data. Don't change it, just leave it in its native state. And you do that so you can always go back later and reprocess if you need to. Then you have developers that usually need to have access, and they're usually going to access data through the staging environment. So they may bring data in, they can read from raw, but they can't change, and they would bring data in from raw to staging. Then you might have operationalized data movement processes. These would be handled by something like an SSIS job or an UZI job or what have you, to process data in some agreed upon certified fashion, and you have these schedules that are set up to move data into your trusted environment. Those are the types of things that would happen there. And the unique thing here is that the data is actually moving into the trusted environment. And the idea in the trusted environment is that you don't want your developers or anybody else for that matter to be able to change data in the trusted environment. All the data that goes into the trusted environment should be moved by these operationalized movement processes. And then applications will simply just pull data directly out of the trusted environment. So, and then finally you have the sandbox, and this is where your data scientists and your business analysts and marketing analysts and things like that, that's kind of their area, that's their playground sort of. And they can pull data from anywhere, and they might do any kind of research they need from that sandbox area. I will warn you about the sandbox a little bit here. When you start sandboxing data, what tends to happen is your analyst and your data scientist or what have you pull data in, and they seem to never delete it. And I think it's just a natural kind of tendency for some people to sort of hoard things a bit. So they get data and they bring it in, they might make some minor changes to it, and then they want to kind of keep it there indefinitely. So it's a good idea to keep some oversight on the sandbox and kind of remind these people that are using the sandbox to, hey, clean up your data when you're done with it. So we don't have, you can easily end up with a sandbox that's bigger than raw staging and trusted environments by several orders of magnitude if you're not careful. So just something to keep an eye out on. So let's talk a bit about the data lake store. And so the data lake store has effectively no limit to scale. It doesn't matter how much data you put in there. You can store the data indefinitely. There's no time limits. It doesn't matter how many files you put in, the size of the individual files, and the throughput that you need to have on it. This is dramatically different than just straight Azure Blob storage, which is your other option. If you try to do this in Azure Blob storage, you would be responsible for monitoring performance, making sure you're not exceeding the performance targets for a single storage account. You might have to spread data across multiple storage accounts to deal with that. You have to make sure you're not hitting file limits and file size limits. So with Data Lake Store, all that is taken care of for you, so you don't have to do any of the management of that. It is optimized for analytic workloads, and by that, I mean it's generally optimized for scan type workloads. So it should run quite a bit faster than blob storage if you're doing that type of workload. So if you want to compare it, Data Lake to blob storage, here's a quick chart for it. Obviously, Data Lake Store optimized for analytics. Azure Blob Storage is general purpose, and it's used by a lot of services in Azure, and it's sort of like generic disk storage. So they are different in the way they're set up and configured. You can use Data Lake Store for any type of big data usage you might see coming through. Even in real-time ingestion, you can store that real-time data in Data Lake Store if you want to do that. You can do the same with blob storage. You are limited by the storage account performance targets. There's a page in the help documentation for Azure that outlines every Azure service and every performance target and limit on that. Some of these change over time, so if you're architecting a solution and you need to decide whether you're going to use blob storage or Data Lake Store, you might want to go up there and check. For example, they just increased the maximum file size, I believe, to 4.5 terabytes, give or take. So it's wise to go up there and check every now and then to make sure that what you did 6 months ago is still the case today. Already mentioned that there's no limits on size. Azure Data Lake Store uses Web HDFS, which is significant. It's just HDFS compatibility, and there's some other issues with that that we'll talk about in a minute. There's no limits to size. The performance should be better in Data Lake Store for these types of workloads. The geo-redundancy, this is, I would look at this as a negative on Data Lake Store. In Data Lake Store, you are protected from a local failure. So if the Data Lake Store loses drives or something like that, and it's something local to the data to its own store, Microsoft can protect you against that. It has multiple copies of your data, and that will all happen seamlessly. You won't have any problems with that. Where blob storage sort of pulls ahead is when you start looking at geo-redundant storage. If you use Data Lake Store, you'll be responsible for architecting a geo-redundant solution yourself. So you'll have to copy your data to 2 different geographic regions if you require that type of redundancy. Both of these are the service state. These are this slide's a little bit dated. Data Lake Store is now GA'd, so they're both generally available. The storage pricing is the other concern. Storage pricing for Data Lake Store is quite a bit more than Azure Blob Storage. So definitely for very cold data that's not going to be accessed very often, you might want to consider storing that in Blob Storage and storing warmer data that you are going to be operating on regularly in Data Lake Store. So some other best practices around storing data in a Data Lake Store. If you do bill through to different organizations within your company, there's no good way to do that in Data Lake Store currently. So what ends up happening is you can see how much money you spend on Data Lake Store, but it's really difficult to divide that up between organizations that are using the store. So in that case, it's best to separate storage by organizational units or applications so that you can fine tune that. There shouldn't be any issue with that because Azure Data Lake Analytics and HDinsight can both access multiple data stores without any problem. So that shouldn't be a limitation, and there's no performance hit to doing that either. So that's the way to get around that. You should try to use time partitioning where you can. The reason for that is just to pick up on some optimizations. For example, if you're using HDinsight and you're running Hive queries, it can do folder elimination. If you're putting folders in by date and filtering on date, it can help you out with that. The more problematic issue that I've run across is the path naming, and this is always a problem because I think as architects we tend to forget that the users may not be quite as, I'm not going to say sophisticated because that's not true, they're sophisticated in a different way, but a marketing person may not know a lot about internal IT structure. And so if you have a standard naming convention, so to speak, and you are trying to use that standard naming convention on folder names, that might be hard for somebody on the business unit to understand. It would probably be hard for people in IT to understand as well. You want the paths to be pretty obvious as to what they are and self-documenting so that business users and analysts can sort of go in there and see the folder and have a pretty good idea of what data to expect in that folder. If you don't do that and you decide later that it's important for you to do that, retrofitting it after the fact is going to be difficult because you're going to have to basically create new folders and move the data into the new folder. So it is a little bit of a daunting project if you've already moved all your data in and then decide to rename everything. So Data Lake Store security, it does have Azure Active Directory integration. It can use a firewall for IP whitelisting, so you can define which machines have access to it. It uses POSIX style permissions on files and directories. This isn't a big deal, except if you come from a pure Windows background, this behaves differently. And if you go through the Azure portal, it tries to make this as painless as possible for people that come from a Windows background. It builds scripts for you in some cases so that it can apply permissions across all or part of a data lake store for you. So, but just keep in mind that it works a little bit differently. There'll be a little bit of a learning curve for your administrators to be able to go figure out the POSIX style permissions. Not a big deal, might take them an hour or two of research to figure it out. It has audit logs for all operations, and your data is encrypted at rest and in flight. So data lake analytics, I mentioned this before, it is elastic scale on a query by query basis. So if you look at this screenshot here, this is a USQL script that I created, and basically it's doing a log extraction. It's got a priority, that's just to balance your jobs amongst each other. And then you see this parallelism slider. Basically you turn this up and you get better parallelism. It does cost more to do that in the portal now. This screenshot's a little dated. It actually tells you how many dollars per minute it costs you to run at that level of parallelism, so you can tell right away how much it's going to cost you. It also has USQL, which I mentioned, which is a combination of SQL and C#. If you are interested in kind of getting your feet wet in USQL, when you deploy Azure Data Lake Analytics, it actually has example data built into it, and you basically just click a button in the portal and it will unzip it and put it out there for you, and then it has some pre-written queries for you on how to use it. If you go through the big data class that we actually have a lab where you go through and write USQL queries to join data from data lake store to SQL database, and you can go at it from that angle. And that is known as, when you do that, that's known as a federated query. It's pretty powerful. There's also a similar feature in Azure SQL Data Warehouse. So if you've ever heard of Polybase, Polybase has the ability to do something very similar to federated queries in that you can define external tables on data and then pull that data into the warehouse for processing. So the advantages to doing these federated queries, it allows you to avoid moving data unnecessarily. So for example, if you have a large amount of data stored in a database, but you're not really going to use it more than once, you might want to just leave it in the database, write a federated query to pull that data. The other is, in certain cases, the data that you're federating, say in a SQL database, is more optimally processed in SQL Server. That is very common. And in those cases, Azure Data Lake Analytics will do predicate pushdown so that a lot of the processing will happen in the SQL database as opposed to Azure Data Lake Analytics. The other issues it helps you get around are data sovereignty issues. So these are more like political barriers to being able to pull all the data into your warehouse or your data store. So in those cases, highly sensitive data is another one where the group that owns the database wants to control access on their end. They don't trust you to control access to their data, so they may not allow you to do an import. Those are all good use cases for federated queries. So, all right. So HDinsight. So HDinsight is the Hadoop stack in Azure. It allows you to deploy Hadoop. It is a platform as a service offering in Azure. There are a variety of different types of HDinsight clusters, and we'll walk through that in a minute so you can see that. And that's really sort of the big win for HDinsight is the concise nature of each cluster that you deploy, on top of not having to manage it. You can also run Hadoop distributions on Azure VMs. So you can run Hortonworks on Azure VMs that you deploy yourself. If you want to do a Cloudera CDH cluster, you can do that. They actually have, the Azure Marketplace actually has templates for some of these so that you can just go into the marketplace and deploy the clusters directly from the marketplace. And it will give you minimum node sizes and things like that so that you don't deploy a cluster that won't work. And those are pretty helpful. If you do HDinsight, you have the option of storing your data in either Azure Data Lake Store or Azure Blob Storage. And some of this depends on which cluster type you choose, but it's all in the portal. When you go through the first time and you set it up, you'll see these options come and go as you change different things on the HDinsight deployment options. So if you do the Hadoop distributions running in Azure, those will use local HDFS, and they will use blob storage, but that's because they don't really know, Cloudera doesn't know anything about blob storage, but the VM has disks that are stored in blob storage, and so to Cloudera, it's just like any other local HDFS store. So if you need to deploy something that is exactly like your on-prem environment, then you should definitely go with a Hadoop distribution running in an Azure VM. But I think you'll see in most cases, HDinsight is probably just as good, if not better, for a lot of scenarios. So the HDinsight architecture, basically, no matter what type of cluster you deploy, the operating system, all the different processing engines, and the storage, it's all the same across all the different types of HDinsight cluster. The HDinsight clusters, when they're deployed, are optimized for whatever type of cluster you choose. So if you choose a Spark cluster, it's going to enable Spark. It's going to change some of the memory configurations, things like that. One thing it won't do is it's not smart enough to go, okay, you're deploying a Spark cluster, which is designed to do in-memory processing. You should deploy it with a VM size with a lot of memory so that you can more effectively process it in-memory queries. It's not smart enough to do that, and that's actually probably a good thing if you are trying to keep costs down during testing or development. So the benefit to this type of deployment is that each machine that I deploy can be deployed for a single use. So, for example, if I'm doing stream ingestion and I want to do processing on stream ingestion, that's it, I can deploy a cluster specifically with Storm on it and do that. If I want to have a Hadoop cluster that simply processes some ETL jobs, then I might just deploy a generic Hadoop cluster, run pig jobs to do some processing on my data, and then store the data back down to store it Azure Data Lake Store or Blob Storage, and then I can spin up another cluster with interactive Hive that users connect to and can query data, that same data that I just processed in the ETL cluster. And then I can scale those two clusters independently of each other. So this is the same slide we saw earlier, and I'm just kind of reiterating the point that the big win here is that you're decoupling your compute from your storage, and you're scaling each one independently of each other. So in addition to being able to have multiple clusters accessing the same storage. So I mentioned creating HDinsight clusters. So let me go through that real quick. I've got a couple of screenshots for it. And then at the end, we can kind of talk about it, and then if you have any questions, we can I can pull up the portal and we can take a look at it. So this is just a screenshot of the Azure portal. It's really easy to create an HDinsight cluster. You can search for it, or you can navigate to it through the menu, and then it'll present you with the options you need to fill out. One of the more interesting configuration screens that you're going to come across is the cluster type configuration. And this is where you decide what type of HDinsight cluster you want to deploy. And so you might choose a Hadoop cluster, you might choose Storm, Spark, or what have you. When you do this, it's going to change the options available in the rest of these menus and drop downs. So if you choose Spark, it's going to come up with different version options depending on what's available for that cluster type. The other thing you'll need to look at is the cluster tier. The premium tier, at least for development, lab, test purposes, you'll almost always go with standard. But for premium tier, that just adds additional enterprise features. So if you are doing things like multi-user auth or auditing, then you're going to want premium feature. I believe there's some other things like compatibility with Apache Ranger is only supported, I think, in premium as well. So in the different HDinsight clusters that we're looking at today, there are a couple of primary use cases that kind of net out. The first one is ETL clusters. So these are typically dedicated clusters. They pull data from multiple sources, they transform data, and then they load data into a database. That database may be Hive, it may be a SQL database, it could be Azure SQL Data Warehouse, it could be any number of other data stores. It's just basically a typical batch processing scenario. So the jobs run a long time. It's a controlled environment. Usually you've got SLAs associated with these types of clusters. So because your jobs need to complete before the boss gets in at 8 o'clock, so that reports can go out. The other type is ad hoc. And sometimes people call this interactive. And in the portal, Microsoft likes to call it interactive. So these are typically defined by being shared clusters, multiple users accessing it. The querying is ad hoc. The data sets are refined for them, and a lot of times the ETL clusters are the ones that do the data refining. You see these in BI scenarios, and the mission of an ad hoc cluster is fast response time, short running jobs. That's the use case. So a lot of times these are Spark clusters, interactive Hive or Hive clusters. If you're not familiar with interactive Hive, if you come from that big data landscape, it's LLAP, long lived in process, which is basically a in-memory processing for Hive, and it's relatively new. So it is available in the portal, but it's ideal for these ad hoc type clusters. And so when you take those into consideration, there are there's a unique feature in HDinsight that we haven't talked about yet, and that is a cluster as a service option. So when you do something like an ETL, run an ETL job, that job might run from say 2 a.m. to 4 a.m. and then it might be done. And rather than deploy an HDinsight cluster and just leave it up all day long, you can actually build in a HDinsight deployment into Azure Data Factory, and Azure Data Factory will spin up an HDinsight cluster, run your ETL and process the data, and then once it's done, it'll just delete the cluster so you don't have to pay for it all day. If you've never used HDinsight and are not used to using Azure, be aware that HDinsight is relatively expensive. It costs a fair amount of money just to spin one up and have it sitting there idle. So You need to be careful with that. If you're going to go practice on your own, especially if you're going to do this in an account that, say, an organizational account that your company is paying for, don't spin up a 10-node HDinsight cluster on Friday afternoon and then go home for the weekend and then come back Monday. You might not have a job when you get back because it's pretty expensive. And in my the last place I worked before I came to Opsgility, we had actually run up a little less than $10,000 in 4 days with somebody spinning up an HDinsight cluster and not tearing it down when they were done. So just something to be aware of. But one of the ways that you get around this in a production environment is you just have Data Factory spin these up on demand so that they can, you just pay for the time you're using them and then you delete them when you're done. The other option to do that, to do the same type of processing, is to use Azure Data Lake Analytics. If your job can be run in Azure Data Lake Analytics, you don't have to spin anything up. You can just have Data Factory launch the job for you. And then you'll just be billed for the time the job runs. All right. So a couple of, I put this slide in because a lot of times we talk about all this stuff and it gets very, it becomes quite a lot, right? And people that are new to big data or new to Azure tend to not understand, what do I use SQL Data Warehouse for versus Data Lake versus HDinsight, or should I just use an on-prem a Hadoop cluster? And this slide basically is just here to kind of show you things like query latency, what's important to you. You know, if you need really low latency, you want to look at something like within memory processing, like HDinsight with Spark. You also have the option of Impala, which is part of the Cloudera distribution, but that would be Azure VMs or on-prem. And then you have things like Data Lake Analytics, which have really high query latency, but you have a little more flexibility with how you get billed for that. So there are just some different trade-offs that you have to consider. All right, so to kind of summarize the big data in Azure and the storage options here, I would say one of the key components is that ability to decouple storage from compute. That is a huge win for Hadoop solutions. And something I haven't talked about much is the newer, for example, like let's say a company has no big data solutions at all. They don't have a lot of expertise in it, and they are thinking they're going to deploy something, and they're not sure if it's going to be successful. It's kind of a big purchase to do a big data project. The people that run big data systems are going to be very expensive. The architects that know it are expensive. You might be able to get consulting companies that can come in and help you with that. But the hardware itself can be quite a lot to spend on something you're not confident in. So one thing I always would recommend to companies that are not 100% sure on the big data project, if it's going to be successful, try it in the cloud, because it's a lot easier for you to just scratch it and start over or change things if it's in the cloud. If you go out and buy 100 nodes and find out 90 days in you really only needed 10, you've got 90 servers sitting around doing nothing. So the cloud is really good for those types of things. The other things that I think are big wins are the cost optimizations, being able to spin up clusters on demand, being able to scale on a query by query basis or an individual cluster basis, depending on whether you're doing HDinsight or Data Lake Analytics, and the ability to scale clusters up and down. So by that, I mean, if I deploy an HDinsight cluster in Azure and it's running for a day or two, and the users are complaining that performance is not so great, or the batch jobs are running too long, I do have the option to just scale it up on the fly. Now, technically, scaling is an online operation. So if I do execute a scale operation, it will do it, and Azure will do that for me. But at some point, some of the services will have to be restarted. And once that happens, you might have jobs that fail. So you still have to do some planning for scale operations, but it's a lot easier to scale an HDinsight cluster than to scale an on-premises cluster or a cluster deployed in Azure VMs. So that pretty much wraps up on my end. I'm going to unmute everyone to see if we have any questions. If I could get it to unmute. Okay. All right, so the unmute is not working. Okay, so the unmute option is not working in GoToMeeting right now. So if anybody has any questions, you can type it in. There's a questions option in here. I'm going to go through. Okay, I'm going to look at, there were a couple of questions already, so I'm going to go ahead and go through those now. All right, big data. Can you go back to the first deck, which had the end-to-end Azure big data workflow? I just want to visualize it. Thanks. Okay. Yes, I can do that. So that was, tell you what, it's easier if I just slideshow from current slide. Nagesh, is this the right slide that you're looking for? Cool. All right. So does anybody else have any questions? Again, if you want to go deeper into this, we do cover it in the big data workshop that'll be run at the beginning of March. We also, our online service, we'll actually be recording that class probably in April, and then it will be in our online service after that. So you'll have that option coming up if you subscribe to the online service. Yeah, okay, so the Lambda architecture. Yeah, so the Lambda architecture is basically the standard architecture for big data solutions. And it stems from having two distinctly different requirements for data ingestion. You have hot path data, which is considered real-time ingestion, and that's the speed layer. And if you look at a traditional architecture where you have OLTP data sources, maybe a couple other data types, and then you have ETL jobs that transform data, they might store it in a staging table and then transform it again and put it into a warehouse or something like that. That would be kind of synonymous with the batch processing side. And then what's missing is that end-to-end streaming side, the real time. And so Lambda considers both of those. Lambda takes the hot path data, like IoT data. If you have a lot, like mobile apps are usually considered coming in through the hot path. And then you ingest that data in real time. You might do some analytics on it. Usually in real-time analytics, it would be something like windowing functions, like what's the average value over the last 5 minutes, and then you could have different types of windowing functions, or you might call some small machine learning function API or something like that, and then you would write that out to a database of some type or possibly a Redis cache, and then you would view it using whatever your BI tool of choice is. We use Power BI because we do a lot of training for Azure. So, but it could be anything. It could be Excel if you wanted it at that point. It is important to remember that on the hot path, you still store the raw data, and it's stored in the same location as your cold path data, usually. It doesn't have to be, but a lot of times it is. And then in the cold path, this is where that classic ETL happens. So you'll still have databases that you're going to have to pull data from, but that data is usually not coming in real time. Usually that data is coming in, every hour or every 4 hours or once a day, depending on the business requirement for that. And then you would do some type of processing on it. This processing is usually on a much larger data set than the data sets you would see in streaming. On the streaming side, the data is just coming in constantly. So a single operation is actually really small. On the batch side, it's just like an ETL job. You have a huge amount of data, and then you run some processing on it. This processing can take hours in a lot of cases. So you'll process the data, do some kind of grooming, just like you do in old school ETL jobs. The difference is you have a whole cluster operating on it typically instead of just a single warehouse. And then you'll store it either on the file system itself, hopefully in a different folder, or you might put it into a database. If you have users that need that data to be very interactive, and it's naturally relational data, then you might just put it back into a SQL database or something like that. And then the same BI tools that you use in your streaming layer or your hot path could be used to pull data from the cold path as well. And a lot of times you'll have dashboards and reports that pull data from both layers. Does that kind of help with the Lambda architecture explanation? There's another architecture that's become pretty popular recently, and it's called the Kappa architecture. And it's been around for a while, but I think it's only really starting to take off in the last year, maybe two. And that architecture basically is just hot path. And so all data comes through the hot path in that architecture. And the hot path ingestion stores the data. And so that's why things like Kafka have become so popular. The big advantage to the Kappa architecture over the Lambda architecture would be that you only have to maintain one code base throughout the entire end-to-end process, right? It's kind of difficult sometimes to write code that does one thing in your hot path and then have code that does the mathematical equivalent in the batch layer. It might be difficult, and they usually are written completely differently. And then so if a business requirement changes or the definition of a value changes, you might have to change it twice. And so you got to maintain two different paths in the Lambda architecture. Whereas in Kappa, everything goes through hot path. You just store everything at the ingestion point, and then if you have to change, you can deploy a whole new layer that's identical with just the changes, and you can kind of test it and run it against your old data. But it's functionally similar, so that it's still the same code base. So hopefully that makes it a little more clear what the different architectures are for big data. Excellent. All right. So I'm going to go ahead and, just in case anybody didn't catch it at the beginning, we do have the big data class coming up. and you can use this bit.ly link. It'll direct you right to the site with the actual description of the class. And if you are interested, you can go ahead and you can sign up for that. Another thing, if you are interested in the online service, if you don't have time to take a week out of your out of work and sit down and do a class end to end over 5 days, there is an online service, and the trial code for that is try Opsgility. So if you want to do that, this course is not there yet. I just sent it out as a reply to one of the questions if you want to see the code, but it's try Opsgility, and the try Opsgility code will give you a 30-day trial as opposed to a 7-day trial on the site. And then we have courses on everything from Azure infrastructure to Azure architecture. If you're less of a data person and more of a general architect, you might be better off in something like the 534 class. We also have another class coming up for that that you might be interested in. So at any rate, you can get onto the site. All that stuff is recorded. Like I said, the big data one is still a couple months out on recording. We have a lot of in-person deliveries we have to do before we can do that. So when is it going to be available? 475. So the 475 recording on our site, or the 475 exam is already out. Okay, our online course, it'll probably get recorded in April because we have in-person deliveries for this class every week in March. So more than likely, we will take the experience from all those, make any necessary adjustments that we have, and then record it in April is my guess. So probably end of April is what you're looking at for that one. You're welcome. All right. Well, if nobody else has any other questions, thank you for attending the webinar. I'm not sure where everybody else is from, but for me it's lunchtime, but I know we get people from all over the world, so wherever you're at, have a good rest of your day. Thank you.